This is a talk by Lawrence Krauss entitled Why Are We Here? And he's going to talk about Einstein's relativity, and he's going to try to deceive us. It's one of the deceptions these people who do relativity try to deceive us with. He's going to omit saying something, and by omitting saying something he's going to try to make people think the wrong thing. So let's get on to the talk.
Throw out everything that went before. In fact, he did something much more difficult. He realized that two pillars of physics, two central pillars of physics that had satisfied the test of experiment for hundreds of years, and were both therefore true, were however inconsistent with each other. Problem. He realized this when he was a high school student, which maybe was unusual. But let me tell you what the two pillars are. I'll come over here because I want to put Galileo over here. Galileo's over here. Galileo discovered 400 years earlier the central tenet of modern physics, which is there's no way you can prove if you're moving at a constant speed. There's no experiment you can show that I'm moving with respect to you and you're not moving with respect to me. And all of you have had this experience one way or another. I was just on the East Coast and I was going to my publisher subjected me to Amtrak back and forth between Washington and New York a few times. But if you're on a train or a subway and you're there and suddenly you see a train on the other track moving, for a second you don't know whether that train's moving or you're moving. And the only way you know is if you feel the shaking or not. But if you forget the shaking, there's no experiment, as Galileo said, there's no experiment you could perform that'll tell you if you're moving at a constant speed or if you're standing still. This is really, in sense, intuitive, but in sense not intuitive, because you all feel like you're standing still, depending on how much coffee or whatever you had down below. But you're not. You're moving right now around the sun at 30 kilometers per second. Okay? And then the sun is moving around the galaxy at 200 kilometers per second. So we're really booting it. But we feel like we're standing still because there's no experiment we can do that'll tell us we're moving. Okay, that's Galileo. Now Maxwell, I've already told you, Maxwell said if you measure the strength of electricity in a laboratory, measure the strength of magnetism in a laboratory, calculate the speed of light. What Einstein realized is that those two things were inconsistent. They don't sound like they are, and that's one of the reasons it's not cooking. Okay? But they are. And so
There you go, one little thing. He's saying these two things are inconsistent, and then he's omitting. They don't sound like they're inconsistent. But anyway, he's going to try to make out they're inconsistent, and he's going to try to come up with a way to make them consistent. So let's carry on.
tried to figure out ways to explain this, and I first began to think about this when my daughter was very young. So I want to explain it in terms of projectile vomit. Okay? So that's when it hit me, literally. Okay. So say I'm dropping.
So he's making a joke of it. He's talking about vomit. He thinks that's a good little thing to make it humorous. Anyway, let's carry on.
Driving my daughter to nursery school as I used to do, and she wasn't very good in the car. Now she loves to drive, but then she did. And so I'd be driving at 20 miles per hour to nursery school, very safe, and she would projectile vomit from the back seat, hitting me in the back of the head, and the projectile vomit would go at 10 miles per hour in the car from the back seat. Okay, so what would someone on the ground here laughing say? Who's on the ground watching? See the car going at 20 miles per hour, and the projectile vomit moving at 10 miles per hour in the car. So how fast would the projectile vomit be moving with respect to me on the ground? What a great crowd. Okay. I knew you were great when you started applauding when I came out. But anyway.
So we'll go through that a bit. We've not got to the deception just yet, but this is the picture I've made for it. You've got a person in a car, projectile vomit, and that goes at 10 miles per hour in the car, and this car's moving at 20 miles per hour. So a person watching outside sees the projectile vomit going at 30 miles per hour. 20 plus 10, 30 miles per hour. So in the car, the vomit is going at 10 miles an hour. The person outside is seeing it going at 30 miles an hour. So that's not a deception just yet. This is pretty much standard, what everybody knows. So we'll carry on to the next bit.
No, it's great that you do that. I was in New York a few weeks ago and I asked my publishers the same question and no one answered. They were all educated at Yale and that was the problem. But anyway, I taught at Yale for many years, so I'm allowed to say that. Anyway, okay, great. Now let's say that my daughter's a 21st century child and she has a laser beam. So she's sitting in the back of the car and she points the laser beam at the back of my head. Okay, the laser beam goes at the speed of light from the back seat to the front seat. What would someone see on the ground? They'll see the laser beam going at the speed of light in the car, and the car going at 20 miles per hour relative to them. So relative to them, the laser beam should be going at the speed of light plus 20 miles per hour. That's what's sensible. But of course, that's impossible. Because what Einstein showed is that's inconsistent. Because Maxwell said, I measure the strength of electricity in the laboratory, I measure the strength of magnetism in the laboratory, I calculate the speed of light from it. If this person on the ground sees a laser beam traveling at the speed of light plus 20 miles per hour, then for them, if they measure the strength of electricity and the strength of magnetism in their lab, it must be different. Because they get the speed of light by measuring the strength of electricity in the lab and the strength of magnetism in the lab. And if it's different for them, then those constants must be different. But if those constants are different, then Galileo says that's impossible. Because if this person measures different strength for electricity and magnetism than that person over here, then this person over here knows that that person's moving. And so what Galileo said, I remind you, is that no experiment can ever give a different answer in the car than on the ground for fundamental laws of physics. So Einstein realized that Maxwell was inconsistent with Galileo. And what did he do? Did he throw out Maxwell? Did he throw out Galileo? No. He did something much more profound. He said, I've got to make those things consistent because they've satisfied the test of the experiment. How can I make them consistent? Well, what is speed? Speed is something, I measure something called speed. It's distance traveled in a certain time. And if the only way that these two things can be consistent is if a person on the ground measures the light ray relative to them to be the speed of light, and a person in the car measures the light ray relative to them to be the speed of light, and as if the person in the car and the ground measure distance and time differently. So they both come up with the same speed. In that case, distance and time are relative constants. They depend upon the observer. And that was his solution to the problem, but this isn't just talk. He said, okay, if that's true, then it must make predictions. And the first prediction is that lengths contract. That means if I'm running with...
So, there you go. That's him dealing with that. Right, so... with this picture... in the car... the car's going at this speed v, which you were saying was 20 miles per hour, and the person in the car is measuring the speed of light, and he's saying, or he or she is saying, that's going at the speed c. Now a person outside can measure the speed of light relative to themselves, and they say that's c. Okay. Now this person is seeing that and that, and so we'll be adding c plus v. So even though this speed is c, you'd be saying this speed will be c plus v. And we're talking particularly the case when v is not 0. So this is what this person is saying. yep, the speed relative to me is c, speed relative to this person is c, but that light is going at a speed c plus v. And he's not making that explicit, Lawrence Krauss is not making that explicitly clear. So he's just deceiving us. If the person here is saying, well, that speed is c, or that speed is c, and that speed is c, then that's just nonsense. That is total and utter nonsense. So that's where he's deceiving us. He's not making it explicitly clear that this speed is c plus v according to this person. Right, and so this is not really new. This sort of thing has been pointed out many times to people like Lawrence Krauss. So we would deal with the response to that criticism. He does deal with it earlier on before he gets onto this bit of the talk. So we pick up now from earlier.
Great. That led to this guy here. Oh, this is a picture of the serpent. I guess I should have shown it. That led. It's going to end. Okay, now that led to this guy. Let's go back. There we go. You know who this guy is. But you wouldn't. I mean, this is Albert Einstein, but Albert Einstein wouldn't have been well, he would have been Albert Einstein, but you wouldn't have heard of him if it hadn't been for Maxwell. Now, I get lots of letters every day, lots of emails, and a lot of them start like this. Everything you think you know is wrong. Half of them are about my politics, and half of them are about my physics.
Right, so he's making a joke of it, but he's getting lots of letters from people telling him that he's wrong about his physics. And I probably know quite a few of those people who send him letters. I've sent letters to people like Brian Cox and they don't reply. I presume people are sending the same sort of thing to Lawrence Krauss and he won't reply to them. He just thinks it's a joke. These people are pointing out to him the absurdity of things like this. That is absurdity when he wants to say, not explain that is c plus v. So he's probably had lots of things and he's just laughed it all off. You can't talk to a person like that.
But the ones that are about the physics, then go on and say this. Now, this is careful. You have to search carefully for the flaw in logic here. They say, everyone thinks I'm crazy. Everyone thought Einstein was crazy. Therefore...
So he's still making a joke of it. I wouldn't write a letter saying something like that, but I suppose some critics are saying things like that.
And then I know to press delete. Okay, so, but the reason I bring up the story is that it really represents what I think is another really important misconception about science, perhaps one of the greatest and most onerous misconceptions about science, and that is that scientific revolutions do away with everything that went before them. And that means for many people that everything we think today is true will tomorrow be wrong, so why bother learning science? Science just seems like a subjective thing that's subject to human fads with no objective reality. But that's exactly wrong. Because what is true today, and by true in science we mean what has satisfied the test of experiment today, will always be true.
And that's the sort of thing that has survived the test of experiment. If that's C and that's V, then that is C plus V. This person is going to say that is C plus V. And that has survived the test of experiment. It survived the test of experiment for his joke one about vomit. vomit going at 10, car going at 20. So this person is going to say it's going at 30.
Newton's laws may have been supplanted at the extremes of scale by general relativity or quantum mechanics, but to describe baseballs or cannonballs or even rocket ships, they're as true today as they were then. And whatever new physics we discover in quantum gravity or whatever, it's not going to change. At the scale of humans, it's got to revert to Newton's laws. A million years from now, whatever we learn in science, if I let a ball go, it's going to fall, as described by Newton's laws. So what has survived the test of experiment never gets thrown out. And the brilliance of Einstein was to do exactly the opposite of what these people claim. He didn't throw out everything that went before him. In fact, he did something much more difficult. He realized that two pillars of physics, two central pillars of physics that had satisfied the test of experiment for hundreds of years, and were both therefore true, were however inconsistent with each other. That's the problem. He realized this when he was a high school student, which maybe was unusual. But let me tell you what the two pillars are. I'll come over here because I want to put Galileo over here. Galileo's over here. Galileo discovered 400 years earlier the central tenet of modern physics, which is there's no way you can prove if you're moving at a constant speed. There's no experiment you can show that I'm moving with respect to you and you're not moving with respect to me. And all of you have had this experience one way or another. I was just on the East Coast and I was one of my publishers subjected me to Amtrak back and forth between Washington and New York a few times.
So there you go. It's true today as ever that if that's C and that's V, then for this person here you've got C plus V. That's true today, and that's the relativity. And if this person is saying that's C, and it's not C plus V but C, well, that's nonsense. He's saying that person's not moving. So C plus V it is. And so that's what I've pointed out. And when you try to communicate this sort of thing to this person, he's just going to laugh it off. He's not making it explicitly clear what's going on with that. What's going on with that? How's he dealing with that? He's not making it clear. It's just a deception. Thank you.